Hi guys, to wrap up our series on solving systems of equations in two variables, we are gonna go ahead do this fifth and final video. So in this case, we are gonna solve this system not by graphing, not by elimination. Not by graphing, not by substitution, but we're gonna solve it by using the elimination method. Okay, so this is how it's gonna go down. So the first step is to fix it so all the equations in the system are in standard form. So an equation is said to be in standard form if it looks like this, ax plus by equals c. In English, x, y on one side, constant on the other, and then it's implied that we have integer coefficients. So if you have fractions, you gotta go. So both of the equations have x and y on the left, but in this case the coefficients are not integers. So let's go ahead and fix it. Okay, let me go ahead and take this top equation, put it in standard form. Again, we already have x, y on the left or on one side. We just want to have integer coefficient. So in this case, the least common denominator between 2 and 6, I believe, is 6. So let's go ahead wipe out the fractions by multiplying both sides by 6. So let's do this. So 6 times the first thing that we see, 2 goes into 6 3 times, and that will leave us with 3 times 7x or 21x. We keep it going. 6 times the next thing that we see, 6 goes into itself once, so we say that cancels, and that will leave us with minus 5y. Equals product of 10 and the 6 that I forgot should give us 60. Fantastic. So let's go ahead and take the second equation and also put it in standard form. X, y equals constant, and we have integer coefficients. So we have 2/5 x plus 4/3 y is equal to 6. So again, let's go ahead and wipe out the fractions. The denominators are 5 and 3, and last time I checked, the least common denominator is 15. So let's go ahead and wipe out the fractions by multiplying both sides by the common denominator just found. So when we keep our cool, 15 times the first term, 5 goes into 15 3 times, and 3 times 2x is 6x. Next product, 3 goes into 15 5 times, and 5 times 4y will give us 20y. Cool. Product of 15 and 6, that should give us 90. I didn't do that in my head, I just copied my notes. Alright, so now both of these equations are now in standard form. Let's go ahead join them to create our new system. So we have 21x minus 5y equals 60, and then 6x, where am I, plus 20y is equal to 90. Okay, so elimination, the gist of the elimination method is to add the equations to eliminate a variable. So our first step is to put the equations in standard form, and then make sure you have integer coefficients. Done. Step 2, we're going to prep up for elimination. How? We want to pick a variable and fix it so the coefficients are opposite, so we can then add them up so they can cancel out. So this is how I normally do it. I would ask myself, if I wanted to eliminate the x's, what would the coefficients have to look like if they're opposite? So I'm like, least common multiple between 21 and 6. I don't know off the top of my head, and I don't want to show some work. So this is not a good problem to illustrate my point. But if I wanted to eliminate the y's, what would the coefficients have to look like? So the least common multiple between 5 and 20 is 20. So if we wanted to eliminate the y's, we will need a positive 20 and a negative 20. So let me go ahead and speak to myself. We're going to eliminate y. How? The least common multiple between their coefficients is 20. So we want to get a positive 20y and a negative 20y. Sometimes we have a nice problem in the sense that we already have one of the desired coefficients, and sometimes we don't have either one. Okay, so in this case, let's consider ourselves lucky. We already have a positive 20 for the coefficient of y. Now we just need to focus on getting the negative 20. Right now, this is negative 5, so I'm like, okay, what do we have to multiply this by to make it look like negative 20? And in this case, we're going to multiply it by 4. Yeah. Let's go ahead, take our time, multiply the top equation by 4. So when we do, let's go ahead, distribute. Product of 4 and 21x will give us 84x. Next product of 4 and negative 5y will give us negative 20y. And product of 4 and 60 will give us 240. Okay, let's go ahead, bring down the second equation, or the bottom equation, because it was perfect. So elimination, how does that work? So step 1, make sure that the equations are in standard form. Done. 2, pick a variable to eliminate. Awesome. 3, identify the least common multiple. Okay, it's 20. 4, make sure that the coefficients are opposite. So handle it. Done. Now reward yourself. Let's go ahead, add the equation to eliminate the desired variable. So we're going to add in a vertical column format. So let me go ahead, put my plus sign. I'll even write add for dramatic effect. Okay, so the sum of negative 20y and 20y will cancel out, and that's kind of what we wanted, because we said let's eliminate y, and that will leave us with 84x plus 6x, which is 90x, equals 240 plus 90 will give us 330. Okay, fantastic. There's a little bit too much space, so let me go ahead, bring these terms in. So to isolate the x, let's go ahead, divide both sides by 90, and you can punch it into your calculator. When we reduce it, well, I know that when we reduce by 10, that will give us 33 over 9, and if we reduce by 3, that will give us 11 over 3. Okay, so let me go ahead, highlight that. So bear in mind, we were not given the liberty to solve the system however we'd like. We were asked to solve the system by elimination. So to recap, how do we solve a system by elimination? So 1, write all the equations in standard form. If you have fractions or decimals, get rid of them. 2, pick a variable to eliminate, and then prep it up. So fix it so the coefficients are opposite. 3, add the equations to eliminate the desired variable, and then 4, solve for whatever variable you're left with. So in this case, we were just left with the x variable, so we're gonna solve for x. So at this point, we're gonna find the value of the other variable, namely y. So let me speak to myself. We're gonna find y. Okay, how are we gonna do that? We're gonna substitute an 11/3 for x into any equation of our liking. It could be an original equation, it could be one of the revised equations, but this is the thing, the original equations are not that nice, so I don't want to look at those. I'm gonna go ahead, look at one of our revised equations. Which one scares me the least? Probably this bottom one right here. Okay, so we have 6x plus 20y equals 90, and we are gonna substitute an 11/3 for x. Fantastic. Okay, so let's do this. Wherever we see an x, we're gonna substitute it with 11/3. So that will give us 6 times 11/3 plus 20y is equal to 90. We take our time. Quotient of 6 and 3 is 2, or 2 goes into 6, 3 goes into 6 2 times, and that will leave us with 22 plus 20y is equal to 90. Work your magic. Isolate the variable term. We'll subtract 22 from both sides, and that will give us 90y is equal to 90 minus 22 will give you 68. Take your time. Oh, did I copy this wrong? Oh, thank you for letting me know. Yeah, so this is 20y, and that magically changed to something not 20y. It's okay. We'll put this in the bloopers. We have no separate bloopers. Who will watch that? I wouldn't watch that. Sorry about that, guys. Okay, so let's go ahead, take our time, and go ahead, isolate the y, divide both sides by 20, and you can either go straight to decimal or you can write it as a fraction. It's a personal choice. If we reduce by 2, that will give us 34 over 10. If we reduce by 2 again, that will give us 17 over 5. If you do the decimal, that's 3 2/5, so that'll be 3.4. It doesn't really matter. Decimals are fine as long as you don't round, and if you're gonna round, then keep it as a fraction. So we found an x, we found a y, so this means that the system definitely has a solution, namely this ordered pair solution given by x, y. So if x is 11/3, then we're gonna write 11/3. If y is 17/5, Cool. Now, if you wanted to check your answer, then just make sure that it's a solution of all the equations in the variable. Okay, guys, so we did it. We wrapped up this unit. Thanks.